let's continue our studies of another important infrastructure service, Bind DNS. Bind DNS, in fact, runs the internet. This is the primary name-to-IP mapping facility used on the internet today. So it features name-to-IP address mapping and also name resolution for DNS clients. And it operates in multiple modes, including a caching-only server, a primary DNS server, as well as a slave server. And it also supports replication of DNS database information between servers, amongst many other features such as dynamic DNS updates and so on. Now we're going to be focusing on setting up the DNS server, which is installation, and operating it in these three modes: caching only, primary, and slave. In caching only mode, which is where we'll focus initially, and this is the mode, default mode that is, in which the server operates, the server caches queries. For example, after we've set up the DNS server and have pointed a client to it either by DHCP or via a static reconfiguration of the IP stack via the etcresolve.conf file, we'll perform a resolution, let's say, of linuxcbt.com, and the server will cache the results for whatever amount of time the server is permitted to cache the results, and subsequent will test the milliseconds return for an initial query of www.linuxcbt.com and other DNS records, and then compare the return time to subsequent queries performed by the same client. We will see the advantages of caching DNS records for whatever period permitted by the authoritative source of the DNS database information. So that's caching only mode. Once we have configured the server's caching and tested that it works, that it's functional, we'll configure the server as a primary DNS server where it can host domains or DNS zones such as linuxcbt.internal or linuxcbt.external. We'll test the configuration and then configure a slave server, which will replicate information from a primary server. So with that said, let's identify the key package. We're going to install it on the remote system, linuxcbt serv 4. We'll do a search in the tree, and this is taking us to the bottom of the list, but at the top of the list we'll see Bind version 9.3, as well as a change-rooted version of Bind, or a program which change roots it, allows it to operate more securely. So this is the main program, Bind, and 9 is the major version. There are other programs as well that are installed by default, such as Bind Utils, which provide utilities on the client side for looking up and working with the server. So back to our notes for a moment. And we should also know that it provides numerous client tools. For example, NSLookup and Dig are two important and commonly used tools. With that said, let's initiate as our first task the installation of Bind on the remote system, linuxcbt serv 4. So from a root shell, because of course we must be root in order to install applications, we'll rpm query all grep bind in search of the Bind server. We see ypbind, which is for NIS, Bind libraries for 9.3, and Bind utilities. So with that said, we need to install the Bind server package, because in fact, if we rpm query list bind-utils, you'll see that it includes the tools that we've just mentioned, Dig, NSLookup, and others such as Host, as well as NSUpdate. Let's include Host as well as another one of those popular tools used to resolve hosts. And man pages are provided for each, and these tools can be executed by any user on the system to look up information. A simple query, of course, would be nslookup www.linuxcbt.com causes nslookup to query a resolver file, resolve.conf, and then to execute a query against one of the DNS servers and have the results returned to us. Similarly, a dig of www.linuxcbt.com will return an answer section as well as additional information including how long the query took to return. So, there are numerous tools. Again, host, nslookup, and dig are three of the tools that are available to you. But the server is not installed on the remote system. So let's yum, and we'll just document it before doing so. Yum-y install bind. This will attempt to install the bind package from the remote server, configured in the yum configuration file. And then we'll just confirm once more once it's complete using RPM query all to ensure that it is indeed installed. And we'll enumerate the contents, there it is, of bind 9.3 by using RPM query list bind, where you'll see the items that are of interest, including loads of documentation as well as key entries. Name.conf, which is the primary configuration file. We'll be using, however, a version in etc. A log rotate entry to rotate the logs produced by the DNS server. An initialization.d or service entry to allow you to start, stop, reload the service. A sysconfig entry which contains startup defaults, which we can examine. A change root admin utility. A keygen utility for DNS as well as DNSSEC. A signature utility. And these utilities, these keygen and signature utilities, allow you, the administrator, to secure communications between communicating DNS servers, such as primary and secondary servers that are under your auspices. And by configuring a key, you ensure that only servers configured with the key will be able to communicate with your server or servers. And the primary daemon is beneath user sbin. It's named as what, or is called or labeled named. This is the name of the primary DNS server itself. And additional tools. Now, we did mention what we have in memory here is the etc sysconfig named entry, and again it includes some startup options such as if you have it change rooted where the root should be, as well as other options, anything that should be disabled or enabled, etc. With that said, named is set up. It's not currently running, however, and in fact, if we lsltr etc init d named, we'll see it exists, but a check config list named, and let's just double check that. And this must be because we SU'd. So let's exit the shell, and we indeed SU'd, so we'll exit again and SSH directly in as root because named wasn't in our path. So 192.168.75.199. And indeed, this server is configured using DHCP, but can be a named server nonetheless. So let's try it again. We'll check config, list named, and then we see it's off in all of the run levels. Now again, you can have check config turn on the service in given run levels by using the level option. So we've installed it. Step 2. Set up service to auto start at boot using, of course, check config with optional level option for the key run levels 3 and 5, the important run levels. But if you just execute check config and the name of the service followed by on, then the service will be turned on in those particular services. Now here it returns only one run level may be specified per instance. So we'll go ahead and indicate one at a time and then rerun check config list name to ensure that it's turned on in those run levels, and it didn't take it, so let's just double check our syntax, and that's because we forgot to turn it on. So check config level 3.5 originally, as we had indicated, on, followed by list does the trick. So now it's on in 3 as well as 5, and we know that our system will start. So check config level 3.5 named on enables the service in run levels 3 and 5. Great. So now the service will start whenever we reboot it, and we want to move forward with the caching only configuration. So task number 3, start named as a caching only DNS server, which is its default implementation. To do so, we'll execute service named start, and then we'll confirm that it's able to cache or look up DNS names by issuing a query against it. So dig followed by the server name at 192, or the IP address 75.199, let's say www.linuxcbt.com, forces a caching only lookup query or request. So it forces or asks our server at 192.168.75.199 to perform a lookup and then cache the results. Let's copy this query into memory and then start the service, then execute the query. So we'll execute service named status, which will tell us momentarily that it's off. Then we'll execute service name. Now notice it doesn't find the etc named.conf file. It doesn't see it. This file needs to be configured. It needs to have some defaults in place. So before we move forward, let's insert a step. Usually this file is available. We'll set this as step 3 or step 4, and our new step 3 will be to configure a default caching only name.conf file. This we definitely need, otherwise the service won't start. And of course there is a sample provided. And we can get a list of the examples provided by using RPM query list. So let's just document that of the bind package to see samples, and then we'll copy. So our next step will be to copy sample to etcnamed.conf and then make the changes that are appropriate. And if there are any files that are included from the name.conf, we'll need to copy them as well. So let's RPM query list bind. This runs off the screen. If we scroll up, however, the etc entries are important. So we'll navigate to the first user share doc bind 933 sample etc directory, where we'll find name.conf. We also see name.root.hints, and this file has a zone defined to look up the various root servers, as well as RFC 1912 zones. If we less or cat the contents, you'll see that it includes zones that most DNS servers should have configured. One for the local host, one for the local domain, and a reverse for the local domain, as well as an IPv6 reverse zone, which points back to local, and an in-address ARPA, again for local, and basic settings. So these are default domains that should be available, and we should ensure that these files are available with the correct zone information. And again, in etc we'll find sample config files. So this name.conf will suffice for our needs. We'll just need to be sure that whatever's referenced within the document is accessible. So for example, here's the file. It includes a global options section, which has query ports or source ports set to port 53. It has a directory, a root directory of var named, which means bind, when it starts as named, will expect to find the config files, or the zone files that is, beneath var named. So be prepared to place the zone files there. Or if you have zone files defined in another instance of bind elsewhere, use those instead, as bind 9.3 on Red Hat should read bind files from other distributions. A dump file gets created, statistics file, memory statistics file. Logging settings are defined with its attached severity, and the file will be created as name.run beneath the data directory. There are different views that are defined to lock the queries into contexts. Here's an example of a view which you'd present to internal clients versus external clients in the event that you're using a DNS server for both purposes. But the suggestion is that you separate your DNS servers physically or logically using perhaps VMware as opposed to relying on software to separate queries from outside and inside folks. And other settings. In fact, this file has more settings than is typically required for a basic caching-only DNS server. So let's go ahead and make the basic modifications to name.conf. Again, we need to copy a sample. In fact, we should copy all of the files beneath the sample structure to our production structure. So let's copy v star to etc. And if it already exists, we'll just overwrite. Then we'll navigate into var named and copy everything from this structure to var named locally. Let's copy v star to var named, and we'll also copy the contents of the slaves subdirectory. There are zones in there to var named slaves. And then let's navigate to etc and modify the name.conf file. We need to disable some options. The query source ports for IPv6 and 4 are fine. The default directory var name is also fine. Most of the directives are fine, but there are some items that we need to disable in the various views. Now, the latest release of Bind implemented by Red Hat presents the ability to lock zones into views or marry zones to views. And in doing so, you can restrict what internal versus external people or one subnet versus non-matching subnet users see when they query your server, if indeed your server functions in that sort of dual role. So with that said, let's scroll through. We've already copied the name.rfc, in fact all the name.files from etc from the sample directory. So we just need to be sure there's nothing that will fail to start, such as using the key generation and a ddns key, which we can define at another time. And here's a section for the key, ddns key. But there are instructions as well. If we want to use the ddns key generator, then we'll need to execute it, generate the tsig keys, and share them with the DNS servers in our environment. For now, just so that we can get the server started, let's disable this key process. And we'll include a comment, disabled, to be able to start the server in caching-only mode. We don't need encryption at this particular stage. So let's keep going through to make sure there's nothing in the external zone. And for the external zone, destinations and clients match anything that doesn't match local nets or local hosts. And this looks pretty clean. So we'll try to start it from the shell, and if it fails, then it will be because of a reference made by this name.conf file that isn't met. So let's save the changes and attempt to start the server using service named start. And if it starts, then we're in business. Let's just return to our documentation. So copy sample star to etc name.conf and var named. So we need the sample zones copied over as well as the sample configuration file. And this is the user share doc bind. So user share doc bind sample star over to etc. And it's going to be simply etc star. Once that's in place, modify etc name.conf, disable ddns keygen sections, and then last but not least, start the server. Using service named start. And once the server is up and running, query the server. So query the server. First we'll use dig. Let's create query the server as a separate section altogether, or a separate task, so that we can perform lookups using different tools. So we'll dig at localhost, since we're connected to the remote system, www.linuxcbt.com. This will perform a caching only lookup. Let's try this. And we'll navigate to the shell, the free shell. That's the wrong shell. We'll close this out, return to the other shell on the remote system, and execute a dig. And there you see, dig has looked up the information that's of interest. Now before we use host and NSLOOKUP, let's discuss what dig returns. Dig returns if the server has been found, the question that was asked by the client, we asked for a lookup of www.linuxcbt.com, an answer section if resolution has been provided, and in our case it has been. The query or the question section, www.linuxcbt.com, translates to the following IP address with the following time to live associated with the record. And it is an internet record, and it's an address resource record. Our server is permitted to cache this record for 3600 seconds. And in subsequent queries, you'll see momentarily that the timer decrements. The authority section describes the DNS servers responsible for the domain in which the record www lives. So for the domain linuxcbt.com, the two DNS servers, and it may not be two for other domains, maybe 3, 4, 10, 20, depending on the size of the domain, but usually you'll find at least two DNS servers, as that is the recommendation for DNS records. So the two DNS servers are ns1 and ns2.linuxgenius.com, with TTLs also of 3600, so chances are the zone as it's configured on the remote DNS server is set to a global TTL of 3600 seconds. And also the query time is returned. It took 259 milliseconds, or a third of a second, for the query to be returned. So dig returns a plethora of information. It returns the question, the answer, authoritative DNS servers, as well as the query time, all returned by dig as opposed to NSLOOKUP. And we see that the server that was queried was the local server using localhost 127.0.0.1 on TCP port 53, and optionally UDP. DNS is a service which makes use of both TCP and UDP. UDP is used by default when the query took place and the size of the message. So again, in comparison to DNS, or to NSLOOKUP for DNS lookups, when we execute NSLOOKUP, the query is the query returns much more detailed information when we use dig. But NSLOOKUP will not default to the local server unless the etcresolve.conf file is set to use the local server first, or you enter NSLOOKUP's interactive mode by entering NSLOOKUP, then indicating server 127.0.0.1, then issuing your query for www.linuxcbt.com. NSLOOKUP returns the result that we wanted, and it tells us whether or not the answer was authoritative or non-authoritative. A non-authoritative answer means that the non-authoritative DNS server, which means neither of ns1 or ns2.linuxgenius.com, responded to this query. In our case, the local system responded, but it could have also have been an upstream DNS server. Let's quit the NSLOOKUP interface again. By contrast, dig returns so much useful information. Now compare and contrast the query time earlier to now. Notice that the query took 5 seconds. Let's look at the earlier query. It took 259 milliseconds. So orders of magnitude faster. And again, also take a look at the TTL for the records. Instead of being 3600 seconds as we saw earlier, the TTL for each of these records is 3381, and it keeps decrementing until the local system is able, or 3381, not 3331, 38381, until the local system runs out of TTL time, at which point it has to request updated information from either NS1 or NS2.linuxgenius.com, the authoritative servers for the linuxcbt.com domain in which we'll find the www record. So dig returns all this useful information, but of course there's the traditional NSLOOKUP tool. NSLOOKUP followed by the name, or optionally NSLOOKUP, then server 127.0.0.1, then the query www.linuxcbt.com will force NSLOOKUP to query the local server. And again, this is what's meant by caching only mode. Note, the server has cached www.linuxcbt.com, evidenced by the decrementing TTL values for the various records associated with the zone. So instead of seeing 3,600 seconds, that is, per query, we're seeing a decrement as time elapses. Now it's down to 3270. You divide 3,600 by 60, that tells you we can hold on to the record www.linuxcbt.com for 60 minutes. And that's what's meant by caching only query. Now let's look up some other items. We'll dig at localhost. Again, dig allows you to indicate on the command line, non-interactively, the server that you'd like to query. So let's query, looking up this time, www.google.com. And you'll see it took 346 milliseconds, roughly a third of a second. The local server was queried, and in the answer section we got one CNAME record which points to multiple A records. So this tells us that round-robin DNS is, which is a load balancing mechanism, is in effect. If we rerun the dig, let's compare 346 milliseconds to the new query. We'll see momentarily a new set of results, which took even longer. This took over 2 seconds. Subsequent query took 51 milliseconds, 32 milliseconds, 30, and so on. So depending on who you've queried, especially for busy hosts like Google.com, you may or may not get results back quickly, but in the grand scheme of things, even 2,000 milliseconds or 2 seconds is not a big deal to wait for such a busy site as www.google.com. They may even use other tools like Host, the main resolution tool, to look up, let's say, ns1.linuxgenius.com, and Host also performs a lookup, returning very little information, only including the fact that the host has a given address. So Host is an optional tool that you may use for lookup purposes. So see, Host www.linuxcbt.com also performs a lookup, and it will do so using the configuration in etcresolve.conf. So note, etcresolve.conf controls the DNS servers that are consulted by lookup tools such as your web browser, let's say your GFTP or LFTP clients, NSLOOKUP, dig, host, etc. So any tool that needs to convert a name such as www.linuxcbt.com to an IP address will invariably consult the contents of etcresolve.conf. It picks out the first name server and performs a query against that name server. So if you want to influence the server that's used, then modify the etcresolve.conf file and include a line for your local server, which is accessible either using the IPv4 address, which is 192.168.75.199, or by using the loopback adapter address of 127.0.0.1. And now when you perform lookups, you don't need to, or no longer need to indicate at localhost. Simply indicate dig ns2linuxgenius.com, and this will perform a lookup against the local system, which took 13 milliseconds, and a subsequent query takes a fraction of that, or 5 seconds. So you can influence your lookup by modifying, or the server that's used, or servers that are used, by modifying your etc resolve.conf file. Now again, our server is operating in caching only mode. We may confirm that it's operating in this mode from a remote system as well. Let's navigate to serve1, and if we cat its etc resolve.conf file, you'll see that it's taught to look up DNS records using the media1 box, then the 199 box. We can switch this order. Let's nano it, and we'll set 199 to be first, followed by 100. Then dig www.linuxcbt.com, a record that is cached, and we see it was returned in rather quickly, 183 milliseconds, and the server that was queried was 199. A subsequent query takes 3 milliseconds. But notice the timer has been reset in the initial query to 3600 milliseconds, or 3600 seconds, that is, which is a minute, a full hour, that is, and it has decremented to 3592 and now 3577. So by virtue of querying from a remote host your caching-only server, it may cause that caching-only server to perform a fresh lookup of the record. Now you may use dig to look up other types of records. Let's say you wanted to find the mail exchanger for a domain. You search for the domain, so dig linuxcbt.com, followed by the record type, such as MX. This will return the mail exchanger of the domain. So let's just list it as an optional query. And that is dig linuxcbt.com MX, lowercase or uppercase, it's case insensitive, queries the domain for mail exchangers. Let's take a look at the results. And here we see the question section was to search linuxcbt.com for any records with MX in the type column. And in the answer section, we see that a record with 3600 milliseconds of type internet and is also a mail exchanger returns a priority 10 mail1.linuxgenius.com. So this is indeed the mail exchanger. And for the IP address of this host, just copy the name and dig or use NSLOOKUP or host to find it. And by the way, we saw a terminating dot at the end, and there we see the translation at the end of the recent paste. You can query with a terminating dot because this dot represents the root of the internet. So, just briefly note, DNS is organized into an upside down or inverted tree, with dot representing the root of the DNS tree. So, example given, we performed a lookup of mail1.linuxgenius.com dot. In this, let's break this down. Dot is equal to root. .com is equal to the top level. Linux Genius is equal to, and we'll just indicate it as .Linux Genius is equal to second level in the DNS tree. And we can show the hierarchy, in fact, by just creating some depth here. And last but not least, mail is equal to third level. So from the top of the tree, what we have is as follows. The root of the DNS structure, which is maintained by the folks on the internet. We've also got .com, which is a top-level domain maintained by the folks on the internet, again, the various authorities. But then, as users and consultants and consumers and business folks on the net, we register second-level domains, such as linuxgenius.com. Then we define records within Linux Genius, such as mail, or within Linux CBT, such as www. So we can use tools like dig as well as NSLOOKUP and host to query the different domains third level, fourth level, so on and so forth. You'll often find with companies that they define multiple internal levels, such as department dot second level, let's say, so it.linuxgenius.com dot. So you can execute queries basically with the terminating dot. It's not a problem. It's understood by the tools such as NSLOOKUP and DIG and host to mean the root of the internet. And when not specified, it's implied anyway. So just keep that in mind. So let's just note that. Note a trailing dot in a DNS query, which also includes your web browser, by the way, is implied and may optionally be indicated, if desired, in any standard internet application. So from the web browser, if we decide we want to hit in a separate tab www.linuxcbt.com, we may hit it without the terminating dot, or after the page is loaded with the terminating dot. In either case, the web browser finds the website and loads the content because the trailing dot is implied anyway. So it provides a means for us to implicitly, or in this case explicitly, indicate the root of the DNS tree, or implicitly by not specifying it. So any standard internet application, which again means web browser, FTP client, wget, NSLOOKUP, DIG, host, etc. So to recap, we've set up a DNS caching only server. We've turned off the key-related or keysig signature-related items in the name.conf file. We've copied the sample files from the user shared document location, and we've set up our environment, disabled a few of the key-related items in the file, and started DNS server, which set us up in a caching-only mode. So back to our graphic. Our VMware instance, which is located within the SUSE Enterprise 10 box, but it's running Red Hat Enterprise 5, and it has currently an IP address of 199, is now a DNS caching-only server. We can perform lookups from any of the hosts, regardless of operating type, against our DNS server in caching-only mode. The DNS server will then consult servers configured in its etcname.conf, or etcresolve.conf, or etcname.conf, such as forwarders, or items in resolve.conf, which the system naturally uses anyway. So if there's a query that cannot be completed by the local DNS server, it will consult DNS servers defined, and that's on the remote system. It will consult DNS servers defined in resolve.conf, or if they're defined in name.conf using the forwarders directive. So with that said, caching only is up. It's a default mode. This is useful. You can use it within your home environment, work environment. Everyone can begin immediately performing resolution of unknown DNS records. Next, we'll look at primary and secondary implementations of DNS.